Question 5, we are given a velocity time graph. Now, before we can go about answering any questions relating to this graph, first, it's important for you to know this. The area, right, of your velocity time graph, it would represent your displacement. Now, the gradient of your velocity time graph would always represent your acceleration. So meaning that every time, maybe whenever they ask you to calculate the displacement between 2 points, you can do so by finding the area or calculating the area for those 2 points. And also, if they ask you to calculate the acceleration between 2 points, you can find the gradient between 2 points, right? Now, let us start with the first, or let us read the information we're given. So we are told that this is a velocity time graph. It illustrates the motion of an object that is initially traveling east. Now, this is important. Initially, it's going to the east. Now, at t is equals to 0, the position of the object is 0, right? So if this was a position time graph, remember on our y-axis, it would have been the position. On our x-axis, it would still be time. Our graph would have started here at point 0 if this was a position time graph. Now, 5.1.1, what is the velocity of the object at t is equals to 0? Now, at t is equals to 0, this is the velocity, and this velocity is equals to 10 meters per second. Now, second question, describe the motion of an object between the interval a and b. Now, always when you're describing because always whenever you have a velocity time graph, this question would always be asked, describing the motion between 2 intervals or 2 points. So when you're describing the motion, you need to make reference to two things. So you need to mention your velocity. What is the velocity, or what's happening to velocity between those 2 points they're asking you about? And lastly, you need to make reference to your acceleration. So this is the approach you're going to use every time they ask you to describe motion between 2 points. Now, let us apply these principles on this question. Now, between A and B, what's happening to your velocity? Now, can you see that your velocity, it doesn't change from A to B because this line is straight. So velocity is constant. So first, I'm going to say 5.1.2. Velocity is constant. Remember, this is between A and B. And lastly, what can we conclude in terms of acceleration? Remember, constant velocity, it means that your acceleration would be equals to 0, right? So because our velocity is constant, this simply means that our acceleration would be equals to 0. Now, this is for 5.1.2. Now, what about 5.1.3? Calculate the acceleration of the object for the interval B and D. Now, let me highlight those two intervals. This is B, this is D. And also, when they ask you, let me just give you a question, right? So which 2 points would represent a phase whereby acceleration was at its highest? Now, acceleration, it will be at its highest between 2 points, whereby those 2 points, right, they would form a long line, or they would form the longest line in the graph. Now, can you see that B to D, this is the longest line we have on the graph. So at this point from B to D, this is where acceleration is at its greatest. So B to D would have a greater acceleration compared to other points in your graph, because why? Your line from B to D, it is the longest, right? Now, what about when you compare the acceleration from BC and the acceleration from BD? Which one would be greater? The acceleration at BD would be greater, so A would be greater, and reason being is why? Because the line of BD is longer than the line of BC. Now, calculating the acceleration from point B to D. So first I'm going to write my coordinates at B, right? So I'm going to start with writing my coordinates as at B and also my coordinates at D. And remember, I said acceleration, you're going to use your gradient formula. So what are my coordinates at B? My x at B, it is this 3. My y at B is 10. My coordinates at D, my x at D, it is this 7 here. My y at D is at negative 10. Now, I'm going to use my gradient formula, y at B minus y at D all over x at B minus x at D. Now, substituting, what is my y at B? My y at my B is 10 minus my y at D, which is negative 10. I'm going to put this in brackets. All divided by my x at B, which is the 3, minus my x at D, which is 7. And now, punching this into your calculator, your acceleration should be equals to 5 meters per second squared. And this would be a negative, because at the top you have a positive, but denominator is negative. But remember, what is acceleration? Acceleration is a vector, meaning that it must have both magnitude as well as direction. Now, if this is negative and this was traveling east. This simply means that your acceleration would be 5 meters per second squared to the west, because it's negative. Now, if they said calculate the magnitude of your acceleration, meaning that the size, you would have left your final answer as that. But because they wanted acceleration, remember acceleration is a vector, meaning that it has both magnitude, which is size, and direction. You need to state the direction as well as the size, just like we did in this instance. All right. Now, moving on to 5.2. Now, with 5.2, they say a learner walks to the shops to buy bread. Now, after walking 200 meters, so let me indicate that here, let's say he walked 200 meters. He realized that he doesn't have enough money, right? And he goes back home. So meaning that if he stopped here, he went back home. And what's the distance back home? The same, 200 meters. Now, overall, this took him 4 minutes from the time he began walking until he returned home. So overall, it took him 4 minutes. Now, determine the learner's displacement. Now, remember, there is a difference between your displacement and distance. Now, what is the difference between the two? Your displacement is a vector, meaning that it has both magnitude and direction. So you have to take into consideration direction. Your distance is a scalar. It has only magnitude or your size, meaning that there's no need for you to determine the direction in this instance. So calculating the displacement, we're going to take the initial as positive. So this is positive, and when he went back, this would be negative. So as a result, your displacement would be 200 plus negative 200, and this would be equals to 0 meters. Now, if they asked us to calculate the distance, which is a scalar, we would have said 200 plus 200. We wouldn't take into consideration the signs because why? Direction is not relevant when you're dealing with scalars. So your distance would have been 400 meters. This is if they ask you to calculate your distance, right? Now, proceeding to the next question. Differentiate between average speed as well as average velocity. So let me explain, let me write them here. So here you have your average speed, and the other side, you have your average velocity. Now, first, I want you to note something. Look at these two terminologies, speed as well as velocity. So your speed is a scalar. Your velocity, it is a vector. So this is the main difference between the two. So these two are similar, but then their difference is that one is a scalar, one is a vector. So what is the formula for your average speed? Your average speed, remember speed, it will be your distance over time. So d over t, normally the speed formula. Average speed, it will be the total distance. So this is in terms of totals now. Total distance divided by the total time taken. What about your average velocity? With regards to your average velocity, it will be your displacement divided by your change in time, right? So now this is the difference between the two. So when you're explaining this, you would say your average speed, it is your total distance divided by your total time. Now, as a result, your average speed, it represents a scalar, so you don't take into consideration your direction. Now, average velocity, it is your displacement or your change in distance, but then just say it is your displacement divided by your change in time. So this is the main difference between these two. Now, the preceding question wants us to calculate the learner's average speed. How would we go about doing this? So I've wrote down the two formulas here. So to calculate my average speed, what is the total distance that the learner traveled? 400. Now, what about the time? Remember, your time must be in terms of seconds. And here they told us that it took him 4 minutes. Now, to convert this 4 minutes to seconds, I would need to multiply the 4 by 60, and this would give me 240 seconds. Now, punching this into my calculator, my average speed would be 1,67 meters per second. Now, what if they asked us to calculate average velocity? We would have said displacement, which is 0, and automatically when your numerator is 0, this would make your whole fraction to be 0, right? So now change in time, right? So our change in time, so remember, if this is 4 minutes, right, I can divide because this distance from here to here, this is the same, 200 and 200, meaning that for the first distance, it took him 2 minutes. For the other distance, you could also say the same. It took him 2 minutes. So our change in time, it would be your t after, time after minus your t before. So what is our time afterwards, right? Our time afterwards, this is the time whereby he started here and he went back home. This is our after, and the blue represents our before. Now our time after, it is 2 minutes. Now converting that to seconds, this would be 120 minus our time before. Our time before is still 2 minutes, which is still the 120. So as a result, your average velocity, it will be 0 over 0, which would be the same as 0 meters per second. Right. And that will be all for this question. For the next video, we're going to be continuing with question 6.